This is William Jackson teaching determination of rate equations. This is Rhoad Jackson, my student, getting ready before the actual video shoot. We're going to learn determination of rate equations. It's basically the rate at which the reaction can occur. So it's the rate of the equation equals the constant K, and then the two reactants. Two reactants, but in this one we're doing two. The rate equation happens. So if it's a zero, it doesn't affect the molecule, doesn't affect the rate. And if it's 1, this is like the first exponent, the rate will be proportional to the concentration of the reactant will be equal to the rate of the equation. If you have a bunch of experiments, if they give you the initial rate, and then using the initial rates from the equations, we can determine how much each concentration affects the rate. Experiment 1. You basically put the concentrations of each of the so the experiment 2 is the lower concentration of A as a nickel makes A. This will be the C2O4. So I'm just putting the numbers. And the rates of each experiment are here. And I'll plug that in here. So the constants will cancel because they equal each other. And then if you cancel the rate equations, it would give you 2. And then this would be just 1. And this would be 2. So if this is 1, you can calculate the y, which is the order of experiment, which is like exponent over here. Do you remember any exponential stuff? That's the phone so far. Okay. I'm just gonna put. Basically, you want to find a number that makes these two sides equal. So if I take this to the first, 2 to the first equals 2. So y. Well, 2 to the first, yeah. 2 times, only 1 2. So if you have like 2 to the second equals 3 times. Okay, and that gives you the y for this thing, for the HgCl. The C2O4, it's CO2 is carbon dioxide, but like that's something else. I'm not sure. And since this is the number 1, we know it's which order do you think? The order is like the proportionality between the concentration and the rate. When I'm talking about first order, that's what this is for. Okay, now that we found out the rate, the order of the HgCl2, we can find out the order of the C2O4. We're basically doing the same exact thing. It will be the rates of experiments. Remember I was saying that you want to have the rate with the higher speed on top, so it'll be easier to do at the end. So I'm going to put experiment 3 on the top and experiment 2 on the bottom. It's like a ratio kind of thing. Because the rates of the 2 experiments are equal to the concentration, proportional to the concentration. And these 2 cancel out. The 2 y's cancel out. Just 1 y, so it doesn't matter. And these